Hello everyone. Today I am going to talk about the project that was completed in third year second semester of our BTech engineering life. So our project title is Human Anomalous Detection in Surveillance Videos using DCCN and MobileNet version 2. So our project comes under the domain deep learning. So what is deep learning? Deep learning is a subset of machine learning which works with the neural networks. So human anomalous detection in surveillance video is a deep learning project aimed at detecting abnormal behavior in video footages. The system utilizes deep learning techniques such as convolution neural networks to identify and categorize human activities. The goal of project is to develop a system that can accurately identify anomalous human activities such as theft, violence, or medical emergencies in a crowded environment. So the existing systems. There are a lot of existing systems in the real world. So some of these existing systems are also like cameras in public places, and also many projects in the use nowadays which are prepared using video compression and attentive learning methods. So some of the existing systems that exist in our real world are a CNN based on visual geometry group network 19, and which extract the descriptive features. These features are then sent into binary support vector machine classifier. So even though this method performs very well, but in some of the cases it may not perform very well. So our proposal, we will be proposing the we will propose to improve the accuracy and efficiency of the work that was done previously by using different algorithms. We are proposing this project that will recognize the act harming humans in a monitor to make the person alert when an anomaly human activity is taking place. The goal of our project is to develop a system that can accurately identify anomalous human activities such as theft, violence, or medical emergencies in a crowded environment. This project is not only helpful in live cameras but is also helpful in recording devices used for human being security. So UML diagrams. So basically we are going to discuss about 5 UML diagrams. So they are activity based diagram, use case diagram, sequence diagrams, data flow diagrams, and system architecture. Activity based diagram. Activity based diagram is the workflow or business process of a system comprising the activities, actions, and decisions. And use case diagram. Use case diagram. A use case diagram is used to illustrate the actors, use cases, and relationships that make up a system's functional needs. Sequence diagram. Sequence diagrams are used to depict the dynamic behavior of a system, including item interaction and their sequential order. Data flow diagram. Data flow diagram is a graphical representation of system data flow and pressure process. As you can see in the picture, the user collects the data and then he splits into testing data and training data. So then he converts these video into frames. Then he sends it for data pre-processing and feature extraction using DCN or different models. Then the model is trained in order to detect the normal and abnormal behavior. System architecture. System architecture. Using standardized UML symbols and notations, a UML system architecture diagram depicts the high-level structure, components, and the interaction of software system. So, what are the methodologies we are going to use in this project are DCCN and MobileNet version 2. So DCCN stands for Deep Convolutional Neural Network, and these are the neural networks designed to process visual data like images or videos. They attract meaningful features, enabling them to recognize complex visual patterns. DCCNs have revolutionized computer vision and achieved impressive performance in tasks like image classification and object detection. And the second methodology that we are going to discuss is MobileNet version 2. MobileNet version 2 is just a transfer learning model, which means A transfer learning model is a pre-trained model that is trained on previous data sets, and it can be used in order to adapt to new environments and trained on the new data set. So MobileNet version 2 is a lightweight convolutional neural network architecture designed for mobile and embedded devices. It uses depth-wise separable convolutions to reduce computational complexity while maintaining the high accuracy while maintaining the high accuracy. So some of the standard data sets which we have used are UCF crime dataset. UCF crime dataset in total consists of 14 directories. So we have considered only 4 directories in those, and they include shooting, road accidents, normal, and fighting. So these are the software requirements and hardware requirements that are necessary for our project to complete. And uh, for code purpose, and now we are looking at the code. So first we need to set the kernel in the PS code, and that is base. And here we are basically loading the data sets and setting the number of epochs and test size, training size, and loading data sets into their particular paths, and mentioning checking whether they are showing the correct images or not. And data distribution, like we are distributing the normal data size, fight data size, accident data size, and shooting data size. So data analysis task is also done, and also we are splitting the training and testing data based upon the testing size that we have given in the above code. Data augmentation is a process of increasing data size by just moving the angles in the images, so that large number of data sets can be generated by using even smaller number of data sets. And we are building a model which is DCCN model, and we have used SGD optimizer in order to optimize the performance of the model. Then we have trained this model by using 20 epochs. Then we have shown that accuracy and loss during training and validation that are given below. We save this model in our PC, so that it can be used in further or future purposes. And also we have calculated accuracy for this model and classification report. So here you can see the confusion matrix for the particular DCCN model. So whenever we want to predict the particular video or image, then the model can be loaded, and the video can be used in order to predict after writing the predict function. And we have also used Adams optimizer in order to improve the performance. This also includes the time taken by the Adams optimizer, accuracy and loss prediction. Finally, we have also saved the model into a path, and also uh, we got a classification report and also the confusion matrix for that decision based on the Adams optimizer. Even though we have used two optimizers such as SGD and Adams optimizer provides a greater accuracy and performance than the SGD optimizer. So here you can see, you can also predict the images by using the particular model which we have saved by loading that model. And now we come to the training with MobileNet version 2. MobileNet version 2, as we have said, it is a transfer learning model. So it trains on the same data set that is used with the DCCN. And as you can see, we have used 20 number of epochs in order for training, and also we got accuracy and loss prediction. The model is saved and classification report and confusion matrix also is generated, and then we save this model into a particular path. Whenever we need to predict a video or a surveillance video, then we load this model and send and as you can see, the it is running and it may take some time. So now we are writing a function for predict path. Then we are now sending our input through this predict function. So it may take some time in order to get the output. So wait, we have not run the classes code or the function. So let me have 1 second. So as you can see here, we have run the classes. Now we will try it again. So it may work now. Now we are running it again. So it is running, and we need to wait for some time in order to get the output. So as you can see, the anomaly activity that is detected is shooting. So now we have detected the anomaly activity. Now we move for the implementation. So in this project, we are able to detect two cases, that are pictures and also video detection. Picture detection is also possible and also video detection is also possible, and these are the confusion matrix that are generated in the project. And thank you uh, thank you for listening to our project. And at the end, we would like to thank our project guide, that is Chidananda K, and Department of IT for their support. Myself, Anil, and my other teammates are Rohit and Sriharsha.